Welcome to another video of Engineering Economics INEN 2373. We're going to continue with examples on marginal cost and the behavior of the producer and how it's attractive to the producer to have an offer in the market, that is to supply the market. So consider another example in which we have now the number of units to be produced being from 100 to 2000, and we again depend on the level of output to understand this table. This is understood to be the product is, as you can see in the fifth column, the price of these units is $25 regardless of the number of units to be sold, and therefore the revenue is just the number of units times the price. The total cost, though, it's a function that fluctuates in a similar fashion due to the diminishing return concept, in which we achieved maximum efficiency at some point, but after a while the costs start to build up again, basically because there is some inefficiencies associated with our manufacturing system if we want to, with the same level of capital, keep producing more. So in this example there is not a particular disclosure on how we achieve the total cost. It is just given, and by subtracting the total cost from the revenue we can obtain the profits. We can also compute the marginal cost and the average total cost, just as we did in the previous table. Remember, the marginal cost is the increment in the total cost given the number of units that we were increasing in the output. So in the first example, in the first row, we increase a total cost of $4,000 out of zero cost at level of 0 units, and we increase 100 units from 0 units. So 4,000 divided by 100, it's $10 a piece. That's the marginal cost, and that happens to be the same as the average total cost, which is just the total cost 4,000 units divided by 100 units. But if we keep going on with this process, then at this next level of activity we increase the cost by $3,000, and those $3,000 have to be spread out over the next 100 units we produce, from 100 to 200, and these 3,000 are 7,000 minus $4,000. So we divide 3,000 over 100 is $30, and that will be the marginal cost. And we have that behavior for the marginal cost. The average total cost is just the total cost divided by the number of units. And as you can see here, that we achieve the maximum level of profits at 6,000 units with $6,000 with 1,100 units. And one thing that you need to notice is that the maximum profits is achieved not at the minimum average total cost. We shouldn't be trying to minimize the cost, but what we should try is to keep producing as long as producing another unit it is not as expensive as the price that we have. And we're going to stop producing the moment that we achieve with the marginal cost the price. And you can see that in the table, in the row with 1,100 units, we can have a price and a marginal cost of 25 units. Is precisely that row when we have the maximum utilities at 6,000, maximum profits at $6,000. We can explain that also in this figure. And this is a very simple figure. The blue line represents the revenue, the red line represents the total cost, and the green line is the difference between the two, which means profits. Now if the green line is below 0, we're actually having losses, because that means that the cost in red exceed the line in blue. But there is a particular region in which we are profitable. That is, there is a region of operation in which there are positive profits, and even more, this area of operation has a maximum which is set up at 1,100. That 1,100 units that we find is precisely the maximum point and the maximum profits. Now, from the class of calculus, you can see that we are going to achieve that point precisely when the slope of the blue line, the revenue, and the slope of the red line, the total cost, are the same. It cannot be before, because before we reach that same slope, the distance between the blue line and the red line is still increasing, and if we exceed the point in which they are the same, then they are converging to the same point, meaning that there is diminution or the reduction of the profits. So in order to maximize the profits, we can make sure that the slope of these two lines are the same. The slope for the total cost is the marginal cost, as we've discussed before. The slope for the revenue is just the price. Now, if we consider the graph that we have here, this graph represents the marginal cost only. That is the curve for the total cost that we have. We compute the derivative of the total cost and we obtain the marginal cost. And the integral at a particular price that we have would be able to compute the total profits that we obtained. And precisely at the particular price, we're gonna, if we offer the product at the price at a particular price, we're gonna want to continue operating the manufacturing side until we reach that price with our marginal cost, and that's why we have the equilibrium at that particular quantity. So based on these two concepts, the supply is going to have an increase in function of marginal cost. The higher the number of products produced, we're going to have a larger marginal cost. The same token, the larger numbers of product to be consumed, we're going to have a decrease in marginal utility. And as we've seen, the consumer is not going to be interested in buying anything more than what the benefit he is getting out of a particular product per dollar spent. That's the marginal utility of the items to be consumed. And at the same time, from the supplier perspective, we're not interested in supplying the demand unless we make some profit. And we can still make a profit as long as the marginal cost is less than or equal to the price. So in this diagram, we can see this equilibrium, and the exercise then is, how do we find this equilibrium? Well, if you have 2 points describing the demand or marginal cost, marginal utility, and you have 2 points describing the supply or marginal cost, then you can find the 2 straight lines that represent the supply and the demand in the most simple of the models, and then we can find where the price is as an equilibrium point, what it should be. In the next video, we will continue with an explanation how to compute the total utilities for the company, and also an estimation for the total cost and the consumer surplus, and of course the equilibrium price and the equilibrium quantity for a particular market under ideal conditions. Thank you.